Well, here we have the products and quotients of rational expressions. We are going to do a little bit of review. We know that, first of all, multiplication is going to be commutative, so it doesn't matter here if this is xy or yx or ab or ba. But what's more important here is for you to understand that when we're taking a rational expression, and we're going to divide it, we're going to do the exact same thing we would do normally, which is to keep, change, and flip. And let's see how that, if we keep this ratio the same, we change the operator, and then we flip this ratio, then we're going to have x multiplied by b, and a will be multiplied by y. All right, bearing that in mind, we're going to look at something just a little bit more complex. And what we'll do is we'll take this we'll take these four quadratics, these two ratios of quadratics, and we're going to be multiplying these ratios of quadratics. But I think what's easier for us to do is for us to simplify each one of these expressions. So when we factor this quadratic, we end up with x plus 2 multiplied by x plus 3. And then similarly, we're going, after we factor this quadratic, we get x plus 4 multiplied by x minus 5. So, and we'll do the same thing for all four of these expressions. When we end up with, it looks a little bit cumbersome here, but what we're going to be doing is we're just going to simplify. We know that since multiplication is commutative, that it's virtually like saying the entire combination of these binomials multiplied by each other. So since that's the case, we can simplify. And let's simplify by getting rid of x plus 2 and x plus 2, x minus 1 and x minus 1. And then we also have x plus 4 and x plus 4 here. So what we're really left with is a very simple expression, x plus 3 over x minus 5. Now, that is fully simplified, but you have to identify what the excluded values are. X cannot be negative 4. X cannot be 1. X can also not be negative 2. And of course, if we look at the denominator here, x cannot be 5. So you need to put those excluded values in if you're going to simplify it to this in this circumstance. All right, let's look at one or two unusual circumstances. Say you have something really complex, and what you end up with is something that looks like this. Well, the temptation is to go simplify, cancel things out, and then say this is 0, but it's really not. We know anything over itself is going to be equal to 1. These cancel out, and the answer is 1. Now this is slightly different, where we see that this is x minus 3. Now if we had multiplied this by negative 1, we would have x minus 3 over negative 1, and then x minus 3 again. But we don't have to do that. We understand that if we've got negative 1, we've got 1 over negative 1, that the answer is negative 1. So whenever you see that, you'll want to take a look to see, well, if I multiply the denominator in this circumstance by negative 1, then will both of these binomials cancel out? In this case, yes. So we know that the answer here is negative 1. But don't be fooled by something like this. These are called conjugates. This is fully simplified. You cannot reduce this any more than what you have right here. All right, let's do one of the problems that you were given. I should have tried to consider whether this fit in my screen or not, but here we are. So we had x squared plus 4x plus 3 over 5x, all of that multiplied by x plus 1 over x plus 5. Now, I circled this because I looked at it and immediately was able to factor this into x plus 3 plus x plus 1. We're going to remember that since our operator is division, we're going to keep change and flip. And this x plus 3 times x plus 1, we multiply it by the x plus 5 that's down there in the bottom. And then we take this 5x and multiply it by x plus 1. Now it's time for us to simplify and cancel. We are able to cancel out x plus 1 from both the numerator and the denominator. And we're left with x plus 3 times x plus 5. So for a completed answer in this circumstance, we FOIL it again, and we end up with x squared plus plus 8x plus 15 over 5x, and that's the final answer. Hope that helps.